In this tutorial, we will show how to add post-tensioning to a model by drawing the tendons, rather than using one of the automated methods. SAFE offers several automated ways to add post-tensioning to the model. One way is to use the flat slab template with the Add PT option, whereby you can specify the layout and the amount of self-load to balance. Another way is to add tendons to the design strips, and then specify the same layout and balancing. However, in this tutorial, we will use neither. Instead, we will draw the tendons. We will start with a two-way flat plate model already developed. Unlike the two automated methods discussed in the introduction, where the program automatically determines the number of strands required to balance a portion of the self-load, when we draw tendons, we will be required to explicitly input the number of strands and hence the force we want in the tendons. The next step will be to define a tendon property. We will use half-inch diameter strands with an area of 0.153 inches squared. Now we can draw our first tendon. We are going to assume that the banded tendons go in the X direction and the distributed tendons in the Y direction. Go to the Draw Tendons command, verify that tendon 1 is selected, and draw a tendon from grid A3 to D3. Leave the draw mode. Now, holding down the Shift key, left-click on the tendon, and from the selection list, select the tendon. We will now assign the tendon properties. Here is where we specify the number of strands per tendon. We will use 2. We will also use unbonded tendons. Reselect the tendon, and next we will assign the stressing load. We will use a jacking stress of 216 KSI, and we will jack from the J end. Select the tendon once more, and we will specify the losses. Losses may be defined in terms of percentage or by inputting detailed values for short and long-term losses. But we will define the losses based on a fixed stress loss, 27 KSI at stressing and 13.5 KSI for long-term. Next, hold down the Shift key and right-click on the tendon, and select the tendon from the list to display the Tendon Object Information form. On the Assignments tab, note that the number of strands is 2, and it is unbonded, as we assigned, and that the loads and losses are also as assigned. On the Geometry tab, if we click in an edit box, we can see the vertical profile. The tendon is broken up into 3 spans with a type of reverse parabola, which is what we want. Span profile information is displayed in the table: the span length, the distances A, B, and C, and the distances from the bottom of the slab to the tendon at the left, intermediate, and right ends. The heights are governed by the values specified in the tendon editing options area. The profile can be edited by typing values into the table or by grabbing the control points. We can also remove a support by selecting a span and clicking the Delete Support button. We can always reset the profile to the default settings if we do not wish to keep our changes. Next, we will replicate the tendon to create a banded group. We now have a total of 7 tendons over a 60-inch bandwidth. Replicate these banded tendons at other locations. Now we will draw a distributed tendon in the Y direction. Again, we will assign 2 strands to each tendon. Checking the profile, make sure that each span is set to parabola. Next, select the tendon and replicate 3 feet on center 16 times. Repeat the selection and replicate 8 times in the other direction. We have now drawn a complete set of banded and distributed tendons. All the tendons we have drawn up to this point have been straight in plan, but they may also be drawn in a segmental manner to pass around openings. First, we will turn on the edge snap. Previously, we assigned the number of strands by selecting the tendon and going to the Assign Tendon Properties command. However, we can accomplish the same thing by doing a right-click on the tendon and using the Assignments tab, click in the Strands Edit box. This pulls up the identical Tendon Property Assign form where we can edit the number of strands. This concludes this tutorial.